something strange entered our solar system this summer. At first, it looked like a comet, glowing tail, icy halo. But when telescopes analyzed what it was releasing, they found chemistry that shouldn't exist in nature. It's venting a metal compound we normally only see in aerospace factories. Nickel refined the way we coat spacecraft engines. And now, it's turned blue, a color comets almost never show. NASA says it's a comet, and most scientists think there's a natural explanation we just haven't figured out yet. But a Harvard astrophysicist has asked the question that won't go away. What if 3I Atlas isn't a comet at all? July 1st, 2025. The Atlas Survey Telescope in Chile detected a faint object moving faster than it should. When astronomers traced its path, they realized it wasn't orbiting our sun. It was passing through on a hyperbolic trajectory, a one-way path from beyond, a visitor from another star system. Only the third confirmed interstellar visitor in history. Oumuamua came first in 2017, a tumbling rock that accelerated without any visible cause. Then it was 2I Borisov in 2019, a textbook comet, icy and familiar. 3I Atlas looked like it would be somewhere in between. It had a glowing coma like a comet, but when telescopes analyzed what it was releasing, they found something wrong. Carbon dioxide, lots of it, and almost no water. And beneath that CO2, nickel, venting into space, with virtually no iron. That's when scientists realized this wasn't going to be routine. Every comet ever studied releases iron and nickel together. They're forged together in dying stars, bonded at the atomic level. You don't get one without the other. Except, now we do. On Earth, separating nickel from iron requires industrial refining. You heat nickel ore with carbon monoxide under controlled conditions. It creates nickel tetracarbonyl, a toxic, volatile gas that breaks down to deposit pure nickel as a coating. Aerospace alloys, corrosion-resistant materials, spacecraft components. It's a human invention, or at least, we thought it was. 3I Atlas seems to be releasing it naturally. But then Hubble photographed something even stranger. When Hubble captured 3I Atlas in July, it showed a jet of material streaming from the nucleus. But it wasn't pointing away from the sun like a normal comet tail. It was pointing toward the sun, an anti-tail. Now, anti-tails aren't unheard of. They can form when dust particles fragment and scatter light in unusual ways. But combined with the nickel emissions and CO2 dominance, it raised a question. What if this isn't sublimation? What if it's venting? If you were a spacecraft, ancient, degraded, and leaking, this is exactly what you'd look like. Corroded metal venting into space, unstable propellant creating erratic plumes, a trajectory that's oddly steady despite all the activity. Most scientists dismiss this outright, but the data keeps not fitting the pattern. Most comets don't fly straight. When they heat up, gas vents unevenly from their surface, like a thruster firing randomly. This pushes them around, causing their path to wobble. 3I Atlas? It's holding a course so steady, you'd almost think something's guiding it. And then there's the geometry. It entered our solar system, nearly aligned with the flat disk where planets orbit. The odds of that happening randomly? About 1 in 500. On October 3rd, 3I Atlas passed unusually close to Mars, near enough for multiple spacecraft to photograph it. NASA's Mars Reconnaissance Orbiter was positioned perfectly. Its camera could capture images 3 times sharper than Hubble, a sideways view that would show the comet's structure in unprecedented detail. The timing was perfect. 2 days earlier, the US government shut down. NASA's website went dark. the Mars observations happened anyway. Spacecraft don't stop for politics. The European Space Agency released their image, a fuzzy white dot. But NASA's high-resolution photos? 4 weeks later, they still haven't been released. Harvard astrophysicist Avi Loeb called it terrestrial stupidity, not extraterrestrial intelligence. But while those images sat in an archive somewhere, and while the comet disappeared behind the sun, hidden from Earth's telescopes, 3i Atlas started transforming. For a month, the only eyes that could see it were solar monitoring satellites, spacecraft designed to watch the sun's corona. And what they captured defied explanation. The comet brightened, not gradually, exponentially, twice as fast as any comet ever recorded. In September, amateur astronomers had photographed it glowing faint green, but as it swung around the sun in late October, it turned blue. And not just blue, bluer than sunlight itself. For a comet, this is shocking. Comets usually redden near the sun. 3i Atlas turned sapphire, bright, ionized, impossible. To brighten that fast and glow that blue, 3i Atlas would need to lose massive amounts of material. NASA's calculations suggest it would shed nearly half of its mass, which means when it emerged from behind the sun in early November, astronomers expected to see a debris cloud, fragments, evidence of violent outgassing. Telescopes captured the first post-perihelion images. The comet looked brighter than before. No debris cloud, no fragmentation, just a steady blue glow, moving through the pre-dawn sky. But how it was moving through the sky added even more strangeness. When 3i Atlas re-emerged from behind the sun, it wasn't moving the way comets normally do. NASA's Jet Propulsion Laboratory detected a non-gravitational acceleration, meaning it wasn't just coasting on gravity anymore. Most comets get a tiny shove when sunlight boils their ice into gas. This one jolted twice, once away from the sun and then once sideways, as if it had changed its own mind. No one's saying it's a spacecraft, but for an object that's supposed to be frozen and dead, it's behaving less like debris and more like intent. So here's where we are. An interstellar object venting refined metals and aerospace alloys, showing an anti-tail, holding an improbably steady course, glowing green, then blue when it shouldn't, accelerating without visible mass loss. So what is it? It could be a comet from a cold star system. 3i Atlas could be ancient, formed around a red dwarf where temperatures were so low that carbon dioxide ice dominated instead of water. Its chemistry could be reacting in ways we've never observed because we've never studied a comet this old, from a system this different. Rare, unprecedented, but natural. Maybe it's a fragment of a destroyed planet. If 3i Atlas came from a planet's metallic core, shattered by collision or stellar catastrophe, it might explain the metal-rich composition. The nickel tetracarbonyl could have formed during the impact itself, under pressures and temperatures that don't normally exist in space. A shard of a dead planet, still glowing from the impact that killed its world. Or it could be something else entirely. It could have been built. If 3i Atlas were artificial, a probe, a relic, something constructed, what would we expect after billions of years in space? Degraded materials venting into vacuum, refined metals in unusual ratios, behavior that looks almost deliberate, but not quite functional. We've imagined alien technology as sleek and geometric, obviously artificial. But what if an object drifted through the galaxy for billions of years? It wouldn't look new. It would look corroded, broken, leaking. Maybe a lot like a weird comet. Loeb isn't claiming it's definitely artificial. He's saying we should at least look with that possibility in mind. Because here's the thing about Occam's razor, the idea that the simplest explanation is usually correct. It only works if you actually have a simple explanation. Right now, Every natural theory requires chemistry we've never observed, behavior we don't understand, and probabilities that strain coincidence. Maybe it's still a comet. Probably it is. But probably isn't certainly, and in that gap lives possibility. If 3I Atlas is artificial, it could mean that billions of years ago, something built it, launched it into the void with instructions we can only guess at. Maybe to search for life, maybe to catalog star systems, maybe just to say, we were here. And that civilization could be gone. Stars die, planets freeze, civilizations vanish. But the probe keeps going, still following programming written by minds that turned to dust eons ago. A ghost ship from a dead world. And if one civilization did this, others did too. Which means the space between stars might be full of them. Ancient machines drifting in silence, each carrying memories of a world that no longer exists. We don't know if that's what 3I Atlas is, but the chemistry is strange enough that we have to ask. And once you've asked, once you've imagined the galaxy full of messages from civilizations that didn't survive to hear the reply, you can't stop wondering, is this one of them? Right now, 3I Atlas is climbing the morning sky, visible through amateur telescopes. In December, it will make its closest approach to Earth, still 270 million kilometers away, but close enough for Hubble and Webb to study it in detail. By March 2026, it will pass Jupiter and speed back toward interstellar space, gone forever. We have one chance to understand it. The scientific community is divided, not over the data, but over what we're willing to imagine it means. The nickel emissions are real, the blue glow is real, the acceleration is real. For most scientists, the default assumption is natural until proven otherwise. That's good science. That's how you avoid chasing every mystery into speculation. But Loeb argues that reflexively dismissing the extraordinary is also bad science, because sometimes reality is stranger than our models allow. Meteorites were dismissed as folklore until we held them. Continental drift was ridiculed until we mapped the seafloor. The universe has repeatedly shown us it's stranger than we assumed. If you forced most astronomers to bet their careers, they'd still bet weird comet. But that sliver of possibility, it's the part that keeps us building better telescopes. Maybe 3I Atlas is just an old comet with chemistry we've never encountered. Maybe the blue glow is just ionized gas, and December observations will show the missing debris cloud. Or maybe, just maybe, it's a reminder that discovery doesn't announce itself. It doesn't wait for us to be ready. Sometimes it just drifts through, and we have to decide. Do we look closer? Or do we let it pass because the implications are too unsettling? Oumuamua came and went before we could study it properly. We're not making that same mistake again. Out there, 3I Atlas is still moving through the dark. Maybe it's a comet. Maybe it's a message. Maybe it's something in between. Whatever it is, it's proof that the unknown still visits us. The universe doesn't demand belief. It invites curiosity. It sends wonders across the void just to see if we're still watching. Because real discovery doesn't begin with data. It begins with a question brave enough to sound impossible.